Hey, good morning everyone. It's Monday, March 17th, and today we're going to start working on the setting screen for my game. In my previous video, I talked about how the concept for my game took shape. If you haven't watched it, I seriously recommend it, but here's a quick summary. I've been working on a deck building roguelike for the past few months. I plan to mix the strategy-heavy and exciting roguelike gameplay with a more cozy and slow-paced town-building experience. In this game, you play as the tadpole god of a town of frogs, and you need to help them rebuild their town and flourish. But of course, my game doesn't even have a main menu, so first, let's get into that. As you saw in the time-lapse, I created a basic menu with the title of the game. I always say this, but remember that everything is subject to change here. My main focus is for things to work first and look good later. Of course, videos are fully visual, so I like to have at least something that looks decent to show. And since I'm a front-end developer, I like having visual representation of my work instead of staring at a black screen with green letters. The main menu has only 3 buttons. The play button starts a new run. Ideally, it would bring the player to the save selection screen, since I plan to enable multiple saves at the same time. But for now, this works. The exit button does what it has to do. And the setting button takes me to the new settings screen. I also created this tabs node, because I didn't like how the default tab container node handles tabs. Having this custom node gives me the flexibility I need to later add proper controller support, moving through the tabs with the bumpers and other kinds of functionalities. With this node, I also started using Godot's metadata field. And to be honest, I found it super useful. I don't know why I haven't used them before. For now, the settings screen only includes audio options, though I plan to add graphics, accessibility, and control mapping settings. Ironically, my game doesn't even have audio yet, but the goal is to implement saving and loading settings, not to make them functional just yet. Good morning again. I spent a few hours already learning about how to save data in Godot, and I learned that there are multiple ways to do so. There is a very useful guide from AnimDex in the Godot forum that summarizes and explains each format very well. I'll leave you a link to it in the description. But here's a quick summary of what I'll be using for Tadgod. Resources. I plan to use resources to save game state information such as town building positions, currency, quests, and unlocked items. There is some debate about the security of resources. Since they can execute code, some argue they pose a risk of embedding malicious functions into save files. However, I align with AnimDex's perspective. Godot already uses resources internally, and my custom resources function similarly. Additionally, since this is a single-player game with local-only save files, there is no reason for players to share or download saves. Resources are also easily editable like JSON files, meaning users could theoretically cheat, skipping levels, unlocking items, or modifying their progress. I may add encryption, but I also believe in letting technical users modify their own data. After all, it's their game, and I'm not here to slap their hands if they choose to tinker with their data. That said, I'm still researching. If you think I should implement a custom loader for resources or use a different file format, let me know in the comments. I'd really appreciate your insights. For now, we are not saving game state just yet. Today I'll focus on config files. Config files are the recommended method for storing user settings. The same security concerns that apply to resources also apply here, so I'll remain cautious and open to encoding suggestions. Unfortunately, today's rabbit hole into security concerns ended up taking all my time. Tomorrow I'll focus on getting the settings properly saved and loaded. Welcome back. Today I made solid progress on how the settings are saved and managed. I also made some changes to what we discussed in the last section. Initially, I planned to use config files for saving user settings, but after carefully analyzing my approach, I decided to switch to JSON instead. The main advantage of JSON is its fast in loading speed, making it a more efficient choice for handling settings as it will take less time to load and process. Additionally, JSON is widely used, lightweight, human-readable, and easy to serialize and deserialize, making it an excellent, efficient choice for handling settings. But the main reason for this change is that I don't need to store vectors, textures, or any special data for settings. In the end, it's just strings, numbers, and objects, which JSON handles perfectly. So yeah, when I first implemented this logic, I built everything to work with config files. But after reviewing my approach, I realized I was constantly converting between dictionaries and config file, which was unnecessary, so I decided to ditch config files entirely. And I don't think there is any need to encrypt this data, since everything is accessible to the user in-game. Let's do a quick walkthrough of the logic. First, I added a new autoload script to handle all settings logic. This doesn't manage the UI, just the logic for handling settings and the settings files itself. And yes, I know what you're thinking, I really need to clean up my autoloads. The number of global scripts is getting out of hand. Most of them are constants, and I'm sure I can merge them into a single script, but that's a problem for future Mike. Anyway, let's take a look at the settings file. The first thing the script does is load the settings from the specified file. This simply parses a string containing the file data. If the file doesn't exist, the script calls a restore all function that resets everything to default values. This function also saves the default settings to the file. One important part of the save function is checking whether the subfolder for saving files exists, since file access doesn't handle this automatically. I also created an update setting function that updates only a specific section with the new values. This is using the UI, allowing real-time updates when the user modifies a setting. Now let's take a look at the UI logic. The two most important functions here are onUpdate and onSave. OnUpdate enables the save and restore buttons if there are changes to be saved or restored. It does this by using a check for changes function, which compares the current form values with both the settings files and the default settings. OnSave maps each field and saves its value using the settings autoloader. Additionally, I have two handy functions: getFieldValue, which returns the value based on the field type, and updateFromFile, which updates field values from the settings files. As you probably noticed, I have a lot of to-dos in this file, because right now the settings screens only include the audio tab. But let me quickly show you how this is working, and tomorrow we'll focus on building out the rest of the settings page. On the right side of the screen, you can see a preview of the final JSON file that gets saved when clicking save. By default, all audio settings are set to 100, and both the save and restore buttons are disabled. But as soon as I move any of the sliders, both button becomes active. Clicking save updates the JSON with the new values and disables the button again. However, the restore button remains enabled, because the current settings differ from the default values. I'm also considering adding an option to restore the specific tab setting to the last save state, but that might be a future addition. To verify that everything works correctly, let's close the game and reopen it to see if the settings are properly loaded from the file. And as you can see, they are. Now clicking restore updates both the form and the JSON file, bringing everything back to its default state. I will call that a success. Good morning, it's Thursday, and with yesterday's changes, most of the heavy lifting is already done. I'm feeling confident that we can wrap up the settings screen by the end of the week. First task of the day, adding all the missing tabs, but first, let me grab some coffee. Alright, I may have underestimated how much work was still left. Even with most of the complex logic out of the way, I still had to refactor some code and create a custom node for custom input type. The good news, almost all tabs are now populated and functional. I'll probably revisit this later to tweak or expand the settings, but for now it covers pretty much everything. Except of course for controllers, which is probably the most complex one yet, since it needs to handle mouse, keyboard and gamepad configuration seamlessly. I left it empty for now to stay focused on getting the other tabs fully functional first. That said, the settings screen is probably the ugliest one I've built so far. With so many grid components and inputs, it's starting to look more like a Google form than a settings screen for a cozy game. Of course, there is not much escape from this, but I know we can do better. For now, I focused heavily on functionality, leaving colors and customization for later. Expect a future video where I'll revisit these screens to properly align with the game's concept. Before wrapping up today, I want to walk you through some of the code changes and show you a custom node I built. It's called Input Stepper, designed to let you pick from a list of options without using dropdowns. It's a cleaner, more intuitive way to handle smaller lists. For example, I'm using it for the font size setting, which cycles through 3 sizes. It's also super customizable. You can enable an empty state by checking Enable Empty, add or remove options on the fly, and even disable the next and previous button if needed. Plus, it has a custom signal that fires whenever the value changes. If you're interested in using the node in your own game or seeing how it works under the hood, let me know in the comments. I could share the node's code. I've got some other open source nodes on GitHub and itch.io, and I'll be happy to add this one too. And while you're at it, don't forget to subscribe and hit the notification bell if you're enjoying the video. I'm working hard on the game and sharing the process with you, so your support really means a lot. Anyway, all tabs are working now, but up next is the biggest challenge yet, key bindings. Good morning, I want to give a quick update before jumping back into the grind. I started with some planning for the key binding screen layout. The first selector lets the user choose their input type. My goal is to make this dynamic, automatically detecting and selecting controller if one is connected, but I also want to give users the freedom to switch this manually to adjust as they prefer. In the controller section, I'm planning to include an icon selector, so users can swap between PlayStation, Xbox, and Switch button icons. Below that, we have each game action listed, with a restore button to reset individual keybinds to default. For the not assigned button, I built a custom node that captures the pressed key and displays them as text. I still need to add error handling for duplicate keybinds and block certain buttons from being reassigned, but for now the focus is on getting the core logic working for displaying and assigning each action. As you saw in the previous timelapse, I also started designing some basic icons for PlayStation buttons. Xbox and Switch versions will come in the next few days. I wanted to focus on getting the core functionality up and running first. Let me walk you through how this works. Controller buttons are saved as indexes, which you can find in the Godot documentation. I created a sprite sheet containing all the button icons. Based on the corresponding index, I adjust the frame's position to show the right button. One challenge I ran into: the left and right triggers aren't treated as buttons, they are motion events. To work this around, I modified the logic to save identifiers for axes and grab the correct icon from the sprite sheet accordingly. This setup will come handy later when mapping inputs, but I think we are finally ready to dive into the key binding functionality. Unfortunately, this took up all the time I had for today, but the good news is I've got most of tomorrow free, so I'll be able to focus on finishing the controller's menu. This took me way longer than expected. Mapping inputs properly, handling errors for repeated inputs, disabling specific keys, and merging the controller functionality into the settings screen was way harder than I thought it would. But now we've got a working controller screen. I can remap buttons, errors show up when inputs are repeated, and the controller input behaves as expected. The number of issues and fixes I had to push through, you wouldn't believe it, and the final result, a tangled mess of spaghetti code. From my experience, coding usually boils down to three approaches. First, the correct way, the clean, readable, perfectly functioning, and easy to debug code we all aspire to write. Unfortunately, this is also the slowest way, and sometimes speed wins over perfection. That's where the second way comes in, the fast way, or as I like to call it, the startup method. Here, you crank out code as fast as possible and ship it. It's the kind of code you know will make you miserable the next time you touch it, so you silently hope it will be someone else's problem. Sadly, I'm the only developer on this game, so guess who's stuck with this mess later? Yeah, that's exactly how the input mapping code looks. It's ugly, but it works. Sometimes that's enough. Oh, and what's the third way, you ask? That's the newer one, the GPT way, or vibe coding as some like to call it. You don't write the code, an AI does it for you. You have no idea how it works or why it breaks half the time. Don't get me wrong, I use ChatGPT and other AI tools too. I ask for workarounds, code snippets I'm too lazy to write, and help with refactoring. But I also double check, edit, and make sure the AI's output is human approved. My code, my responsibility. So yeah, these are the three ways of coding. Now I'm closing this project for the weekend because my brain is officially fried. See you on Monday with a fully working setting screen, hopefully. Welcome back, it's Tuesday the 25th now. I didn't have time to record an update yesterday, but we made solid progress with the settings. Most of the settings are not connected to the game itself. Changing language, full screen mode, and even control settings are working as expected. As usual, the controls took the longest to set up, but they are working smoothly now. The language settings setup was pretty straightforward. I haven't shown this yet, but I've been storing most of the in-game text in a spreadsheet with English and Spanish translations. Adding a new language is as easy as creating a new column and filling in the text. This setup is based on Godot's documentation, so I highly recommend checking that out if you are considering multi-language support for your game. Adding new text is just as easy. I extend the sheet with more rows and set the key translations for each text. Once saved as a CSV, Godot automatically processes the language data through the project settings. In my settings autoload, all I needed to do was load in the user's saved language settings and update the translation server locale. If you'd like a more detailed breakdown on how to set up multi-language support in your game, let me know in the comments. I did run into a minor issue with the font I'm using. It doesn't support some special characters in Spanish, and I imagine the same will happen with Portuguese, French, Japanese, etc. But since the aesthetics are still a work in progress, I'm not stressing over this now. The only major thing left now is controller support, which I'm tackling today. See you soon! Good afternoon, after a long day I finally got the controller support set up. Let me quickly show you how it works. I configure it so tabs toggle with the controller bumpers. Honestly, it looks pretty bad, but every time I think about redesigning the UI, I remind myself to stay focused on functionality. That said, I can now navigate all the UI elements with my controller. Nice. The only weird bug I found, because of course there is one, is in the controls tab. The keyboard navigation works perfectly, but with the controller the last input skips past restore controls and lands on cancel instead. I spent a good chunk of time debugging it, but I'm clueless. So I'm closing this feature for now and leaving it as a bug ticket for future Mike to deal with. Let's wrap up everything we accomplished in today's video. We built a basic main menu that connects both the game scene and the settings, created an autoload that handles saving and loading settings in JSON format, added the settings scene which is fully connected with the autoload. If we ever need to remove or add new options, it's just as simple as adding them to the tree, set a metadata key, and drop them into the corresponding tab array. Some of the input here don't do anything yet, but we'll flesh those out as the game progresses. And finally, settings persist between game sessions. We have made serious progress with these past few devloads. I'm hoping we can keep this momentum going for future videos. If you enjoyed this and want to stay updated on Tadgod's development, consider subscribing and hitting the notification bell. Also, if you have any suggestions regarding the new settings screen, let me know in the comments. Thanks so much for watching and I'll see you in the next video. Bye!